When you look up at the night sky, have you ever wondered how many light years away those distant stars are? Is a light year really a distance we can imagine? And how can humans measure the vast distances in the universe, where everything is so immense and far away? Today, we will explore one of the most fascinating units of measurement that humans have invented, the light year, and understand why it can help us unravel the mysteries of this vast universe. A light year is not a unit of time, as its name might confuse you. In fact, it is a unit of distance, commonly used in astronomy to measure the distance between celestial objects. By definition, a light year is the distance that light, traveling at the incredible speed of 299,792 kilometers per second, covers in 1 year. If you calculate it, light would travel about 9.46 trillion kilometers in 1 year. Imagine this. If you were to drive a car at 100 kilometers per hour without stopping, it would take you about 10 million years to cover the distance equivalent to 1 light year. This number helps us realize the vastness of the universe and why we need a special unit to measure it. In the universe, the distances between stars and galaxies are too vast to measure in conventional units like kilometers. For example, if we used kilometers to measure the distance from Earth to Proxima Centauri, the nearest star outside our solar system, the number would be 40 trillion kilometers. Using such large numbers is not only complicated but also prone to confusion. The light year simplifies these enormous numbers, making communication and research in astronomy more convenient. The distance from Earth to Proxima Centauri, instead of being 40 trillion kilometers, is just 4.24 light years. A light year doesn't just measure distance, it also carries a meaning related to time. When you look at a star that is 10 light years away, the light from that star has taken 10 years to reach your eyes. This means that you are seeing its image from the past, as it existed 10 years ago. This phenomenon makes the night sky a snapshot of the universe's past. The light from distant stars takes us on a time travel journey, revealing how celestial objects have existed and evolved over millions of years. The concept of the light year originates from humanity's understanding of the speed of light. In the 17th century, Danish astronomer Ole Romer was the first to demonstrate that light has a finite speed. While observing Jupiter's moon Io, Romer noticed that the timing of when Io entered Jupiter's shadow changed depending on Earth's position in its orbit around the Sun. He concluded that light took time to travel, a discovery that changed our understanding of the universe. One of the clearest applications of the light year is measuring the distance to Proxima Centauri, the nearest star outside our solar system. Located 4.24 light years away, light from this star takes over 4 years to reach Earth. This means that if humans ever developed a spacecraft capable of traveling at the speed of light, it would still take more than 4 years to reach this star, an exciting yet challenging prospect. Before the concept of the light year, humans tried to measure the speed of light. One of the pioneers was Galileo Galilei, who experimented by standing on 2 hills with lanterns. But the speed of light was too fast for him to measure accurately. It wasn't until the 17th century that Ole Romer succeeded, using Jupiter's moon Io to calculate the speed. Light is the only means by which we can see and measure distances in space. From distant stars, light brings information about their position, size, and even their chemical composition. For example, light from stars in the Andromeda Galaxy, 2.5 million light-years away, reveals that this galaxy is moving toward us at hundreds of kilometers per second. In 1987, astronomers on Earth observed light from a supernova explosion, known as SN 1987A. The explosion occurred 168,000 light-years away. This means that the explosion happened long before humans existed, and the light took tens of thousands of years to reach us. This event not only marked an important step in astronomical research, but also served as a reminder of the unimaginable scale of the universe. The Crab Nebula, one of the most famous supernova remnants, is 6,500 light-years away from Earth. The explosion that formed this nebula was observed by Chinese and Arab astronomers in 1054. When we look at the nebula today, we are witnessing an event that happened more than 6,500 years ago. When we venture into space, units like kilometers, meters, or miles become useless. The distances between celestial objects are too vast to be measured with the familiar units we use in everyday life. For example, if you wanted to measure the distance from Earth to the nearest star outside our solar system, Proxima Centauri, in kilometers, you would have to write a long, impossible-to-comprehend number, about 40 trillion kilometers. This is a number that is hard to imagine. That is why scientists created the light year as a tool to simplify these massive numbers. 1 light year equals about 9.46 trillion kilometers, and therefore, it helps reduce the complexity when talking about distances in space. The distance from Earth to Proxima Centauri is only 4.24 light years, which is much easier to understand than the number 40 trillion kilometers. Not only does the light year help us easily measure the distance to nearby stars, but it also provides an overview of the vast distances in the universe. Imagine standing on Earth and looking toward the Andromeda Galaxy, the closest galaxy to the Milky Way. The distance from Earth to Andromeda is about 2.5 million light-years. This means that light from Andromeda will take up to 2.5 million years to reach Earth. This is a colossal distance that we can only measure using light years. Furthermore, when we look at the light from these distant galaxies, we are not only seeing their present, but also their past. That's why studying stars and galaxies is crucial for exploring the evolution of the universe. A light year is not just a unit of distance. It has a special connection with time. The distance between us and a distant star is not something we can see instantly. When you look at a star that is 1 light year away, you are seeing its image as it was when its light started traveling from it a year ago. The light from that star had to travel for an entire year before reaching us. This becomes even clearer when we look at stars and galaxies that are farther away. Light from galaxies that are millions of light years away will show us their image from the past, perhaps millions of years ago. Thanks to light years, scientists can look back in time and learn how celestial objects formed and evolved. One of the fascinating applications of the light year in space research is the ability to explore the evolution of galaxies and stars. The light year allows astronomers to observe galaxies at different stages of their history. For example, the James Webb Space Telescope, one of the most powerful telescopes ever created, can observe galaxies that are billions of light years away. The images it captures are not just light from these galaxies, but the history of the universe, helping us understand how galaxies form and change over time. The universe is vast, and when we compare the size of Earth to that of galaxies, we are incredibly small. For instance, the Milky Way, where we live, has a diameter of about 100,000 light-years, while the Andromeda Galaxy, our nearest neighbor, is about 2.5 million light-years away. These numbers make us feel tiny, but at the same time, they spark curiosity and the desire to explore. While we may never travel to these distant stars, our intellect and technology can help us see and understand them. Light is not only the medium through which we perceive objects around us, but it is also the messenger from stars, galaxies, and cosmic phenomena. It brings information about their position, characteristics, and even their existence from the past. When we look at the light from a star that is millions of light years away, we are not just seeing a shining star, but a witness to a long, endless process in space and time. Although we are just small beings in the vast universe, humans have learned to use intellect and technology to reach beyond the limits set by nature. Measuring distances in light years is not just a research tool. It is also a way for us to feel connected to and appreciate the universe. Every time we look up at the sky, we are not only admiring stars, but also looking into the past of the very universe we live in. Thanks to the light year, We can connect distances not only in space but also in time, helping us better understand our origins and the vast universe we are just beginning to explore. The light year is not just a unit of measurement. It is the key to unlocking the door to the exploration of the vast universe. It helps us connect space and time, bringing us closer to the mysteries of stars, galaxies, and the evolution of the universe. Each light year holds a piece of the past, a story of the formation and development of the universe in which we live. Though we are tiny creatures in an immense universe, through the light year, humans can broaden their vision, explore the wonders, and feel the grandeur of this universe. And perhaps it is this curiosity that will guide us on our ongoing journey to understand the boundless cosmos.